Good afternoon, sir. This is Natas Gavia, and we are discuss the overview of data warehouse architecture components, approaches to building the data warehouse, and then the data warehouse life cycle. Data warehouse architecture is complex as it's an information system that contains historical and quantitative data from multiple sources. Uh, to design an effective and efficient data warehouse, we need to understand and analyze the business needs and construct a business analysis framework. And these are the views on designing the data warehouse, the top-down view, data source view, the data warehouse view, the business query view, uh, which is the view of data from the viewpoint of the end user. Then the three-tier data warehouse architecture, the bottom tier, the middle tier, the top tier, and then this is the diagram that depicts the three-tier architecture of a data warehouse. And then we have the components of the data warehouse architecture, data warehouse architecture, diagram of the Ralph Kimball 1998 architecture. Then the source system, an operation system whose function is to capture the transaction of the business. Source systems may be in form of data existing in production operational system, archives, external data from outside the company, provide input for data staging area. Data staging area is a major process that includes sub-processes, for example, extracting, transformation, and loading components of data warehouse contain core ETL to ensure that data resident in the data warehouse is relevant and useful to the business users. High quality to ensure quality information. Another one, data storage component. A data mart is a subset of data warehouse facts and summary data that provide users with information specific to their requirements. Then scope implementation. This is the diagram, the an overview of data warehousing and data marts. Components of data warehouse to be contained. Dependent used in the top-down approach created from warehouse deprecated, and then the independent using bottom-up approach created from warehouse and then scaled down less expensive version of data warehouse designed for a department or BU. Organization may have multiple data marts difficult to integrate. Then information delivery component. This is to enable the process of subscribing for data warehouse information and having it delivered to one or more destinations according to some user specified scheduling algorithm. Ad hoc reports, complex query tools, multi-dimensional analysis, all up data mining, executive information systems, and then web browsers. Then you have metadata component is a data about the data that describes the data warehouse. It is used for building, maintaining, managing, and using the data warehouse. Metadata is simply defined as data about data. The data that are used to represent other data is known as metadata. In other words, you can see that metadata is the same as data that leads us to the true data. Metadata response is an integral part of data warehouse system. It contains the following metadata: business metadata, operation metadata, mapping metadata, and then algorithm metadata. Another component, management and control component. This is the component. This component coordinates the services and activities within the data warehouse. Its source of information is the metadata. Security and privacy management matters reference from the multiple sources, data quality checks, managing and updating metadata, auditing and reporting data warehouse usage and status, packing data, duplicating, subsetting, and distributing data, backup and recovery, and data warehouse storage management. Data ware models as another component. From the perspective of data warehouse architecture, we have the following data warehouse model: the virtual warehouse, data mart, enterprise. Virtual warehouse, it's a view of an operation data warehouse is known as a data warehouse. It is easy to build a virtual warehouse. Building a virtual warehouse requires access capacity and operation database services. We have the data mart. Data mart contains a subset of organized data. Wide data, this subset of data is valuable to specific groups of an organization. Then data mats are small in size, are customized by department. Source of data matters. Departmental structured data warehouse, data matter flexible. Then enterprise warehouse to provide us enterprise-wide data integration is integrated from operation systems and external information providers. Uh, then the load manager, this component performs the operations required to extract and load processes. The size and complexity of the load manager varies between specific solutions from one data warehouse to other. Then load manager architecture as a component, extract the data from source system, first load the extracted data into temporary data store, perform simple transformations into structures similar to the one in the data warehouse. Extract data from source as another component. Then first load transformations affect the system of data processing. It's more effective to load the data into relational database prior to applying from transformations and checks. Then simple transformations. Following it may be required to perform simple transformations. After this has been completed, we are in position to do the complex checks. Warehouse manager is responsible for the warehouse management process. It consists of the third-party system software, C program, and shell scripting. Then warehouse manager architecture includes the following: the controlling process, stored procedures, backup or recovery to SQL scripts. Another component, operations performed by warehouse manager analyzes data to perform consistency and refresh integrity checks, creates indexes, business views, partition views against the base, transforms and merges the source data to published data warehouse, backup the data into the data warehouse, achieves the data that has reached the end of its captured life. Also analyzes query profiles to determine index and abbreviations are appropriate. Query manager responsible for directing the queries to the tables. You also responsible for scheduling the execution of the queries posed by the user. The following are the screenshots shows the architecture of a query manager, which includes query redirection via C2 stored procedures, query management to query scheduling via C2, query scheduling via third-party software. Then the detailed information is not kept online, rather it is uploaded to the next level of detail and then achieved to tape. Summary information is part of data warehouse that stores predefined aggregation. The points to be noted about summary information are as follows. Summary information speeds up the performance of common queries. It increases the operation cost. It needs to be updated whenever new data is uploaded into the data warehouse. It may not have been backed up since it can be deleted fresh from the detailed information. I'll stop them from there. Another one we start from approaches to building data warehouse.
So, when you talk about approaches to building data warehouses, there are three: top down, bottom up, and hybrid. So, what do we mean by the word bottom up approach to building a data warehouse? bottom up, extract data from the operation systems, transform it, perform an ETLS, and then drive the respective data marts. Bottom down, build individual data marts one by one from the operation systems, combine them, the data marts, into a data warehouse. The hybrid will combine the two up, the top down and the bottom up. So here we have some advantages of the top down approach and the bottom up approach. So one of the advantages is enterprise view of data. In enterprise view of data, we have inherited architecture and single-center data storage, centralized, may see quick results. Takes longer is one of the disadvantages, high exposure to failure, high needs of cross-function skills. And then when we look at a bottom-up approach, we have faster and easier implementation is one of the advantages. We have favorable turn on investments and proof of concept, and could be done incrementally, slowly by slowly. And disadvantages, each data mart has its own narrow view. For example, here we are combining various data marts. And then when we talk about the hybrid, a compromise drawing from the advantages and disadvantages of each of the previously discussed approaches. One of the benefits of the hybrid, we have enterprise long terms can be easily achieved. So this is of the future use. Fast data marts can be really derived and proof of concept. And here we have steps on coming up with the hybrid data mart. You have to first plan and define the requirements of the system, create a sounding architecture, confront and standardize the data content, implement the data warehouse. So those are one of the approaches. So now we can further go and look at other approaches of building data warehouses. We have heterogeneous approaches, query-driven approach, process-driven approach, and then we look at the disadvantages of these other combined approaches to data warehousing. And then here we have what we call the data life cycle. The data warehouse life cycle is used to indicate the phases or the steps a data warehouse goes through between when it's initiated and how long it's going to be in use. So the diagram here below shows the data warehouse cycle. We have the project planning. After that, we gather requirements, and we have steps in gathering requirements. We have the dimensional modeling. We have the physical design, data staging and data design development, deployment, maintenance, and growth. So further on, we go to the project planning. It involves scope definition, understanding the business objectives. Here we can understand and collect requirements. And then furthermore, in collecting requirements, we have what we call focusing technology and the end user and the applications. Similarly, it includes installation of selected products. Still we are in the requirements gathering. So then we go to the dimensional modeling. In the dimension modeling, we are going to look at things like fact tables, association dimensions and attributes, and numeric facts. For the physical design, here we are going to also look at the OLP databases and the ETL in data staging. That is extraction, transforming, and loading of the data. So, and then we look at the deployment, the end user, who is going to be using this data warehouse. How are they going to extract information from this data warehouse? That is the data warehouse life cycle. And then we look at the maintenance of this data warehouse life cycle. How is it going to grow? Because data is continuous, it's going to be added on. So that's how we look at it. So that is a picture that depicts a typical data warehouse. So one of the last things that we are going to look at is data warehouse requirements gathering analysis, because this is one of the steps in coming up with the data warehouse life cycle. We have talked about data modeling, we have ETL development, We have ETL, that is extracting, transforming, and loading of data review. We have a peer review. We test with the peers. We have ELT testing. And last, we have report development, deployment, and production environment. Thank you so much. That was Bwire Conrad, Nasaze Jovia, and Mugera Ishma.